Hey everyone, so I'm back finally with the part 2 of the tutorial. Um I know it took a really long time for this video to come out, but I just want to say that I've been at work. I've been doing some stuff. I've, I've been doing I've gotten way better at CV2 in the process of making this video and while doing it, so that's why I'm going to be including a CV2 tutorial as well as the recap of the CV1, also including Foxy's AI, as you can see right here, was a working camera system. So that's going to be that's going to be awesome. I'm going to be going over, going over all of sorry. I'm going to be re-going over all of the CV1 stuff. I'm going to be re-going over this and providing a more detailed AI, also as well as a more detailed explanation, as well as for this. I'm also going to be including Foxy's AI for CV1. If there's no other tutorials on how to do that. I don't know if there is. So I'm just so anyways, there's also gonna be you won't see it in the video, but I'm gonna be working on the CV2 for Foxy's AI because I finished the CV1 for regular animatronics. It's right here. I'm in CV2 for this if I didn't say that. So that's gonna be interesting. Also, if my mic sounds weird, that's because I'm not using the Oculus mic to record this. I'm using my phone microphone because this one it's not working right. I tried it yesterday and it was working just fine, but now it's not. Now I'm recording the video, second take, it's not. So that's fun. Anyways, this video is going to be split up into different sections. It's going to be split up into the CV. It's going to be split up into 4 different sections. 2 for this, 2 for the CV1 and CV2 regular, and 2 for the Foxy CV1 and CV2. If you want me to make a tutorial on the power system, some moving, some moving variables, or anything like that, just tell me in the comments. I read those, if you couldn't tell already from my previous tutorial. So you can give any suggestions on what I should make a tutorial for next, and I'll probably consider it. Okay, I'm gonna stop yapping and let's just get on with the first part. Okay, so to start, we're gonna need a model. Now, you can just make this whatever you want. I'm gonna use a rectangle because it's easier to work with than a complex model. So I'm just gonna be going with a simple white rectangle. Okay, so after you have your model, you want to go and get CV1 state machine. Should look like this. Those 3 arrows on it, and you want to place it down. Okay, next, if you already have the search for state open, then you should see the CV1 state like right near it. And that's where that's gonna be using this. So let's get that, and we're gonna need however many states that you want your animatronic to have +1, and that +1 is gonna be your door phase. So I'm gonna have 2, 3, and then 4 for the door. Right. So now that you have now that you have your states, what you're gonna need to do is go to your connect tool on your maker pen and drag the body of the state machine over to your first state. That should light it up. That should have it lit up. There should be a transparent green line connecting the two. And so once you have that, now you're gonna want to drag the state to the next state that you want, and then so forth till you reach the door state. And then once you're done with that, you're gonna want to drag the state back to your first state, and like that. So now what you should be seeing is the states are making a loop of sorts. They're looping in a pattern. See it going there? It's going like this. Your state should be looping. Okay, so now that you're done with that, now we need to set up the animation for the states. So you're gonna want is get a CV1 animation gizmo right here, and once you you good? All right. Anyways, once you have that, sorry about that. You're gonna want to place however many animation gizmos as your state chips +1. That's gonna be for your jump scare animation. So I'm gonna be placing 2, 3, 4, and then 5 up there. Now before we start, let's go and configure and then the animation gizmo. This menu should pop up, and what you want to do in this menu, you want to click stop at end. Now what this is gonna do is it's gonna make it so that after it plays, it's gonna stop so that we can continue on to the next one, so that it'll actually play any other animation that are using it. I'm gonna toggle that on for all of your animation gizmos, because what stop at end does, what if happens if you don't toggle stop at end, is it's gonna break your animation. Please, so I don't know how to explain this, but when this plays and as this plays, this might still be registered as playing. So both of them are going to be playing at the same time. But since this one was on first, it's only going to show the visual with this one. So when you toggle stop at end, so that when it plays and it ends, it's going to allow the visual, this one, to be shown. So basically what I'm saying is, it makes it so your visuals work. That's all I'm saying. So it's less buggy. What you see is less buggy and more fixed and consistent in how the animations play, one after the other. And this goes for any animation you're doing where there's multiple animation gizmos connected to the same object, you just want to have stop and end toggled, unless it's looping, unless you want just like a looping platform or animation, then you can not have it stop end. But anyways, what we're doing, okay, so now what you're gonna do is you can move, transform, rotate, whatever. You're gonna want to move your animatronic to states you want to be at. So I'm gonna move it right here, and then I'm gonna go to connect again, and then drag my animatronic to its gold pin on the animation gizmo. What you see when you do that is it should say object added to animation. Now, okay, so that means that whatever, say, you can now edit your object inside the animation gizmo by pressing edit and then go into the animation. So it'll start at the position you put it at when you put it in the animation gizmo. Now you can move it, do whatever you want with it inside the animation gizmo. So now you're gonna move your electronic to the next position and then do the same thing. You're gonna connect, drag, object added to animation. Now if you've done this twice, the same thing, it's gonna say object removed from animation. That's a no good. That's a no good. It's not connected now, so you can just drag it back and make it object add to animation, and that's, you got it. No, you just wanna move, connect, drag, add it to animation. Move, connect, drag, add it to animation. Yeah, just like that. Basically like that. Okay, so now for your jump scare animation, you can do the same thing you did before, but now after you add it to your animation gizmo, you can go press edit and then edit the animation gizmo. Now you have the animation menu, animation gizmo menu popped up. Now you want to click add frame. So now we have 2 frames in our animation, and on that last frame you can do whatever. On the frame that you added, you can do whatever you want with it. I'm gonna make it slide forward, so, and when you press play, it's gonna play an animation that you just did with the 2 frames. And this is gonna be your jump scare animation. You can add however many frames you want to make it, but just know that this is gonna be your jump scare animation right here. Okay, so now what you want to do is you still have your connect tool open and you just ignored all that. You want to drag this gold plate, this red play pin has a 0 on it. Your animation is going to drag that to the red pin on the state, the one that says on enter when you hover over it. You want to do that for all your states. So I'm gonna do that. So now you should be seeing is now your animatronic is looping along with your animation gizmo, with your states. That's good. That's very good. And you should have it looking like this. Now what we need is to make the actual AI. So first thing you're gonna need is a CV1 timer chip. If this keyboard can stop moving when we get a timer chip. Alright, like this, there's a little circle thingy. I don't know, I don't actually know what that is. But you're gonna want to place it somewhere near the state that you want it to be at. And then after that, you want to get a CV1 random chip. So I'm gonna go ahead and get this. Should have a dice on the front of it. You're gonna place that next to your timer chip. And then after that, you're gonna get a CV1 comparer chip. It's really tall, has 2 bars on the front. I'm gonna place that next to your random chip. Now, you can copy and, after we set this up, you can copy and paste this for each one of your states, but I'm not gonna do that. Instead, I'm actually gonna get a combinator chip, a CV1 combinator chip, and I'm gonna copy and paste that once. So now I have 2 combinator chips. I'm gonna connect the output to one of the inputs of my first combinator chip. Now what this is doing is it's adding all these values together. So it's adding these 3 values and then putting that into this, which is adds these other 2 values to this one to output that, which we're gonna link to the on-off of our timer chip. Now so now we can have multiple outputs, multiple inputs power the same timer chip. And we'll get into that later. But for now, let's link the time expired ping, the red output, to the generate signal of our random chip right here, the red to the red. And we're gonna go to the red another time, linking the random number, the red output, the random chip to the red input of the compare chip. Now, let's configure our compare chip. Go to mode, click that, and scroll down to the second to last option, which is less than or equal. So now it should, so if you're doing the same thing I'm doing, it should look like this. And now what you're gonna do is we're gonna need to set up all these values. So first, we're gonna go into our state chips, and we're gonna configure our states. And you should see min time and state. You're gonna want to set that value to however many seconds you want minimum for the animatronic to be in that state, minus 0.1. So I want mine to be 3 seconds each. So I'm gonna put 2.9. So however many seconds minus 1.9. So however many seconds, take a 1 away from that, then add 0.9 to it. So if you want 3 seconds, put 2.9, 4 seconds, 3.9, and so on. I'm gonna put 2.9 for all of these because I want 3 seconds. And what that's gonna do, it's gonna have time for us to actually run all this math before immediately sending us to the next state. So I'm gonna need it now. Let's configure the green input of our timer chip. You're gonna want to click directly on that 0 there, and then put in the real second. Then put in however many seconds you want each state to last times 10. So if you want 30 seconds, do put 30, 4 seconds, 40, 1 second, 10, 2 seconds, 20, and so on and so on. So there we go. Now what you're seeing in your states is that it's gonna take some time before it fully loops all your states. And now what we want is we're gonna configure the values in our random chip. So this green input in our random chip is the minimum value it's going to output, and the blue is the maximum. So what we're going to substitute those for is the minimum value it's going to take for it to have a successful movement opportunity, and the maximum it's going to take for it to have a successful movement opportunity. So I'm going to configure the blue chip and put 20 for just as basic FNAF AI. Put 20 there, and for the minimum I'm going to put 1 because that's the lowest value that an animatronic can move with. And you're gonna want to configure your compare chip to. You're gonna want to configure this blue pin on your compare chip to your actual AI value that you're gonna be using. So I'm gonna put this at 20, so that's gonna be successful every time. And what this compare chip is doing is comparing the randomly generated number to our AI value, and if it's less than or equal to our AI value, it's gonna output a value of 1, which we can then connect to this arrow, connect to these arrows to give a successful movement opportunity. And if it outputs 0, it's not going to have a successful movement opportunity. So we can go to connect and then drag this red less than or equal to a green output to all these arrows, except for, and this is important, except for the one that resets us back to the start of the loop. Don't want to wire that there. So I'm not going to. And now that we have all this set up, what I'm going to do is I'm going to put these values in so that we can actually have these generate instead of it always just equaling 1. I'm going to connect all the inputs of these combinator chips into the green output of our state chip, which is in state. I'm going to connect all these to the combinator chips, to all the inputs of the combinator chips. Now, if you have more states than what I have, you're going to need more combinator chips. Just make sure you link the outputs to one final combinator chip. But anyways, once we have that, now we see that every 3 seconds it's gonna ping a random number, and if that random number is compared to, it's gonna be allowed to move. So I'm gonna set this to value 5, so it has less of a chance. No, I just real okay. Wait. Yeah, no. I was wrong about the state timer. I was wrong. So regard what I said, you're actually gonna need to put the seconds you put plus 0.1. So that was a mistake on my part. Sorry. You're gonna need to put 4.1 if you have 4 seconds, 3.1 if you have 3 seconds, blah blah blah. And why we're changing it is because it's moving on to the next state 1 millisecond before this is actually doing its math. So we need it to move on 1 millisecond before 1 millisecond after it does the math, so that it can actually do the math in that millisecond and decide if it shall pass or not. So now you see is that because I put a value of 5, it's taking some time. It's taking quite some time to actually generate a number. You see, it's generating multiple numbers between 1 and 20, and they're not being successful, which means it's not moving until, see, it's 5 now. So that's a successful movement opportunity. And when the output 0, it cannot move. Oh. So there you go. Now you have a much more simplified, much more conserved, simplified slash simplified version of a recap of a normal AI, except we're not done yet. No. We still need to do the jump scare animation, the math stuff. So now you're gonna need is a CV1 toggle button. So I'm gonna get that. I spelled anyways, CV1 toggle button V1 legacy. You're gonna place that down. Now I'm gonna put another one down, and with this one, we can now reset. I'm gonna connect the current toggle value of the second one to the reset of our state machine. And what happens is when I press it, it's gonna automatically reset back to our first state, and it's gonna stay there until I unpress the toggle button, in which our circuits are gonna activate again. So this is really nice if you're just looking to have your animatronics pause while you work on your game without them getting in the way. If you still have some work to do after your animatronics AI, so that's really nice. It's what I'm doing in my game too. So anyways, now let's get our first toggle button, the one that we're actually going to be using for the door, and we're going to get another comparator chip. This time we're not going to configure it. We're going to place down in the middle of our final state in our animation, jump scare animation gizmo, and we're gonna link the right input chip of that comparator chip to the current toggle value of the toggle button. I'm gonna get another combinator because you're gonna need another combinator because I was wrong again. Sorry. You're actually gonna want to put the output of the combinator chip into the red pin that we talked about earlier. So get this. And now what you're gonna do is you're gonna link the current toggle value to an input of that combinator chip into you're gonna current toggle value into combinator chip, and then you're gonna get another one, and now you're gonna connect another one of those to the done pin, the only output pin of your animation gizmo, which is done. And I'll explain this later. This is why we don't just connect this one to this, and I'll go into that. But for now, let's configure the other input pin of our comparator chip to a value of 1. And all this is going to do is going to compare the output of this combinator chip to the value of 1, and if it equals 1, it's going to make and 1 is going to output a value of 1. Now, if you want to make this more accurate, you can configure this and scroll down to greater than or equal, but you probably won't need that unless you're in very specific situations that I won't go into detail now, but might come up if you're making one of these games. So now after you have all this, you're going to want another timer chip. You want to spawn in another CV1 timer chip down here. And what I'm going to do is configure that time to however many seconds you want for the animatronics to take while it's in the door state before you get jump scared. So I'm going to put 5 seconds times 10 until you get jump scared. So, however many seconds times 10. So that means it's going to take 5 seconds. Because, no, let me explain why we do times 10 every time. It's because this is actually measured, the timer is actually measured in milliseconds and not actual seconds. So 10 milliseconds are equal to 1 second. And so every time you put 10, if you ever put time you put 1 in this timer chip, it's gonna output a value. It's gonna the timer is gonna last 1 millisecond. So that's why we need to times the number by 10 so that it actually takes however many seconds we want before it gets outputted. So now you want to connect the on-off of your timer chip to the in state of your door state. And you're going to connect the reset of your timer chip to the if red equals green, or the red output of your compare chip. And you're also going to connect that output to the arrow leading back to your first state. You're going to connect that to the output of the red chip, and you're going to connect the red output of your timer chip into the play of your animation gizmo. It's known as the red input. Okay, so now what this is going to do is it's going to check if it's not going to if either the the door is pressed or the jump scare animation's done. Then it's gonna send us back to the first state so that we're not just stuck looping the jump scare animation over and over again. It's actually gonna stop and go back to the beginning after we're done with it. So now, and if we don't have the door closed, we don't have the toggle door closed, it's gonna wait 5 seconds, consistently 5 seconds, until the state is exited, and it's gonna play our animation gizmo after those 5 seconds if we don't have the door closed already. Now, if you remember when we configured these states, you don't actually need to have a time listed for the state, since it's not going to be exited until we tell the state that it can be exited, because there's no math going on in this state. It's just these. There is math, but it's not the AI math. It's just this that's happening in the states. So now let's give it a test run. Let's wait a little bit. It's going through, and now we've reached the door phase. See, after 5 seconds, it's played, and now it's reset back to start. Now let's close the door this time and see what happens. So as you can see, it's in door phase, and boom, it's just gonna reset back immediately to the start. Now what you can do to make this longer is configure your state and put however many seconds in, and this time we don't need a modifier or anything. Just put however many seconds in before you want your animatronic can leave. your animatronic will snap back once the door is closed. So I'm gonna put 4. When we have the door closed, it's gonna take 4 seconds to go back. So let's see. There we go. 4 seconds. Now we can let's put this at a higher value. Then our jump scare timer, and see that it still goes back to start. It doesn't play it because we've consistently resetting the timer because our door is closed. So that means the timer won't actually be playing until our door is not closed and we're in the same state again. So there we go. There's a recap of the CV1 animatronic AI with some extra optimization modifications and quality of life changes added to it to make this easier, and may not look prettier, but it's sure better than whatever we had in the first tutorial going on over here with the copy and pasted. So that's the end of part 1. If you already watched, if you needed a recap, then this part was a one for you. But other than that, we're gonna go on to the next 3 parts, which I actually haven't seen anyone talk about. We're going to detail 2, which is the Foxy CV1 AI, as well as the CV2 AI for your Foxy animatronic and your regular animatronic for more advanced, for people looking for CV2 explanations. So there we have it. I'll see y'all in next. Alright, so now that we have this first part done, now I'm going to be teaching you how to make the Foxy variant of the FNAF AI. So to start, we're gonna need an RC car set, which go in a package like this. I'll explain later, but for now, we're gonna scale. I'm gonna click scale and then scale this car way down. Alright, so now once you got it pretty small, we can now configure the car and scroll down to tags and type in what tag you want your camera to have. Now what this tag is going to do is when we use this tag, it's going to be referring to the RC car. So I'm going to give it a tag of just cam C. You can make this tag whatever you want. It doesn't have to be very long. It just has to have a unique tag that only it is going to have. Now let's press this plus sign right here, and it's going to add it to the list of tags that our RC car has. Okay, so now we're going to get CV1 buttons. CV1 buttons. We're going to place however many cameras you want. So I'm going to place 3 buttons. Now I'm going to configure them. Now I'm just going to name them. We go up to message. I'm just going to name them 1, 2, and 3. Now the name doesn't really matter. You just need to know that you just need to have them have distinct names so you actually know which one you're talking about. So now let's get a CV1 object respawner. If it's gonna let me type that in. An object respawner. It should be a little green circle like this, what I have right now. You can place this wherever you want. Just place however many buttons you have. Doesn't really matter. Just place them down. And just to note, whichever direction these arrows are facing, the green and red arrows, that's the direction that your camera is going to be facing. And your camera is going to spawn in the middle of this object respawner where the little white dot is. So keep that in mind. And it's going to be pointing in the direction that the arrows are pointing at. So I'm going to make this one face towards the ground almost. I'm going to make this one face towards our other CV1 animatronic. And I'm just going to make this one point towards the whole scene. Actually, I'm going to move this down a little bit so that's facing more in front of it. Smooth this a little bit. Place these cameras wherever you want. Just make sure that you want them where you want them. And that this is where you want your camera to be placed at. So now we're going to need to wire these buttons to the cameras, to the object respawners. But before we do that, let's configure these real quick. So press configure, select your object respawner, and then you're gonna go tag to respawn. Now this is very important. You're gonna want to type in the tag that you gave your RC car exactly, like it's very specific. So you need to specifically what your tag gave you, or it's not gonna work. And then you're gonna click change rotation on respawn. You're gonna check that. Change clear velocity on respawn should already be checked. You don't need to change anything else. But you're gonna give all your object. You're gonna do this for all your object respawners. So I'm gonna type in cam C, and then change rotation on respawn. Cam C and change rotation on respawn. So once you have that, now let's go ahead and finally wire our cameras to the object respawner. So go to the connect tool and then drag the when button is pressed of what button you want to connect to one of your cameras to the red tag, to the red arrow right here that says respawn object by tag. You're going to drag it to that. And you're going to do this for all your buttons. And make sure you only have one button connecting to one object respawner, or else it's going to try and respawn it to multiple places at once, and that is going to break it. So now when we press it, you can see now our RC car teleports to it with a really big orange square and then just falls to the ground. Now this is good, but we don't want this. So let's configure our RC car. Anyways, you configure your RC car, tick respawn, untick use default visual effects, and then set the delay all the way to the lowest value. Just drag the slider all the way back, as you can see. So yeah, respawn, use default visual effects is off, and then we're gonna actually click freeze, and we're gonna freeze our RC car. Now this is gonna stop it from falling to the ground, and it's also gonna stop it from having that weird visual effect. So now we click it. The only thing that should be left is a little trail, which we cannot change, going to each of the cameras. Now, this tablet right here, this is what's you're gonna be viewing your cameras on. Pick this up, and as you can see, here's me. We're now viewing it from our RC car's perspective. See when it changes cameras almost instantly, and that's how you make a camera system in Rec Room. Now, this is gonna lead into our Foxy, because as you know, we need these cameras. So that's an extra tutorial, an extra pre-tutorial before we actually get started on the AI, and we're gonna get started on that now. Okay, so now that we have our cameras done, we can actually get started on the AI. So first thing you need again is the state machine, because this is gonna be really similar to a normal AI, but we're just gonna change the AI. Yeah. So how you have that, you're gonna get a state chip. You're gonna get your state chips, and here's 1, 2. Place however many you want plus the door phase again. This time the door phase will be substituted for our running animation, so that'll work differently. Okay, so you have those. You can now go to connect and wire all these together. Again, want to go forward from your first state all the way to your last state, and then back to your first state. Okay, so now what we want is the animations. We need a model and the animations for that model. So, oh my god. So let's make one. Let's make a model. I want to make like a blue cube. And this is gonna be my model. Alright, so now you have your model in place. Let's get a CV1 animation gizmo. And wait, it'll let me place those down as well. +1 for that sweet, sweet jump scare animation. Alright, now let's make our stages / states, whatever. Let's move it. Let's move our animation, move our model, press connect, and then drag it to the gold pin to add it to the animation. move it, connect it. I'm gonna make my movement smaller because until the door phase, which I'm gonna move completely, I'm gonna move really far, and then this is actually going. We're actually gonna this after our door phase animation is finished playing. That's when we're gonna activate a jump scare animation. So I'm gonna move right here for animation. You're just gonna be floating in the air. Don't really matter. But now I'm gonna configure all these animation gizmos to stop and end. This little button right here, you're gonna take that for all of them. Now let's connect. And then wire all our animation gizmos to the on enter of our state chips. I'm gonna do this. And then now I'm gonna wire the done to our jump scare animation. So now I'm gonna actually animate our door and jump scare animation. So I'm gonna have this guy just kind of float up to here, represent him running to our door, and then let's make him do that. There. Now I can just reconnect it. And there we go. Now, jump scare animation should be playing repeatedly. That's fine. We're gonna start on the AI now. So now what you're gonna get is a CV1 trigger volume. Trigger volume V1 Legacy. It's almost completely transparent when you search it up. Just wanna grab that. You wanna go to the camera that you want it to be, or it to be watching Foxy Cameras. You want to go to your selected camera and then drag the box completely over it. Drag it all the way over your object respawner. Now that you have that, now we can configure our trigger volume. We can change this to keep track of objects and filter by tag. We're gonna get the tag from our camera. If you were here before, you can, if you skip to this part, add tags to your camera. So my tag is cam C, so I'm gonna put in cam C here. And now what this is gonna do is it's only gonna detect it when our camera or RC car is in the camera or in the trigger volume. So again, you can add tags, add a tag to your camera by just scrolling down to tags, typing where you want, and then pressing this plus button right here. Refreeze this. I'm gonna drag it back up here. And now you can see what camera is in this camera. The total currently in zone is gonna have the output of 1 constantly, and we're gonna use that for our AI. So what you want to get next is a comparative and 2 timer chips. No, just 1 timer chip. We'll need 1 timer chip. You need a random chip. And actually, we need 2 compare chips. Sorry, 2 compare chips. And we're gonna. No, actually, instead of a compare chip, don't need 2 compare chips. Let's get a Boolean chip. And this one is gonna have the word "and" on it. We're gonna use to compare these two. So what this is gonna do is it's gonna compare these values, and if they're the same value, if they're all the same value, it's gonna output 1 right here. And we're gonna use that to allow it to move. Let's get our second comparative. We're gonna use these 2 comparatives to have our "and." So I was right. You do need 2 comparatives, but you also need a Boolean chip. So sorry for the confusion. Sorry for the confusion, everybody. Then you're gonna get a combinator chip, a CV1 combinator chip. And we're gonna use that to reset back to the start. And to accompany that, you're gonna get CV1 toggle button. I'm gonna use this one to reset our animatronic by going to current toggle and dragging that to the reset our state machine. And I press that. It's gonna stay in our state. Alright. Now you can switch this to in state if you want. I'm just gonna do that. Now let's go to current toggle value of our door toggle or door button. our door toggle button. We're gonna drag the current toggle value using connect. I'm gonna drag that to any one of these values in the combinator chip. We're gonna also drag the done our jump scare animation to it. And we're also gonna drag this output to it also. And then we're gonna drag the output of our combinator chip to this arrow leading back to the start of the loop and to the stop of this animation gizmo, of our door animation gizmo. Now that we have that set up, let's actually start working on this. So, let's start by connecting our time expired ping to our generate signal or random chip, and then the random number for the output of our random chip to our first compare chip, and then the output of our compare chip to the first value of our AND chip. And then we're gonna take the output, red output of our second compare chip, and then also put that into the AND chip. And then we're gonna get the red input of our second compare chip, and then drag that to the total currently in zone, or the green arrow of our trigger volume V1. Actually, we're not gonna put the red output, we're gonna put the green output into there. And now we're gonna disconnect the red output of our AND chip from this compare chip. We're gonna instead put it in all the remaining arrows leading out of our states. So what this all does is, first it takes the time, and then after the time it generates a random number between this min and this maximum, and then it compares that number to our AI value that we set here, which is currently 0. And if it equals the AI value, it's going to output 1, which is then also compared to if the camera is currently in the position that we want. And if it's not in that position, it's going to output value of 1 in this else output. And if both of those are successful, it's going to allow our animatronic to move. So now let's go ahead and set these values. So we're gonna go to configure on our maker pen, and we're gonna configure our second compare chip. The only input left should be the green one, and we're gonna configure that to a value of 1. which means if there's one camera, there's one in it, and it's no. Oh, wow. Then it's not going to send this else output. Now let's configure the green output of our timer chip. We're going to set that to however many seconds you want before your animatronic will be able to progress to the next stage. So I'm going to put times 10. By the way, it's always going to be that for these timer chips. It's going to put the seconds you want times 10. I'm going to put 30. So it'll take 3 seconds. Move forward. And then let's go to our random chip where you configure this green value to our minimum AI value. We want our animatronic to have to be successful. We're going to put that at 1. And we're going to put the blue, which is the max, at our maximum AI value, which is 20. It's 20. You can put this at whatever you want. I'm just going to put it 20 because that's, the default. And now we're going to configure this compare chip itself. We're going to configure the compare chip itself. Go to load, scroll down to the second to last option, which is less than or equal to. And now this little thing should be facing downwards. Now we're going to configure the green output, or green input. Sorry, the green input of our compare chip to our actual AI value, which I'm going to put in, which is just 18. So it's mostly successful. Now we're going to get another combinator chip. Now, if you have more than 3 states, you're going to need multiple combinator chips. But I'm using 3 states, so I just need 1 combinator chip. If you have multiple, if you need multiple combinator chips, you can just spawn in however many you need. You need to spawn in 1 for every 3 states you have. And then drag your output into the outputs of both these combinator chips into the output of this final combinator chip. And make sure all your combinator chips are outputting into the same combinator chip. And that one is going to output the total value of all these. So now that we have that set up, let's drag the in state of all of our state chips into the input values of our combinator chip. So I'm going to do that. Again, I only need 3. I only had 3 states, 3 normal states. So I'm only need 1 combinator chip. If you need more, do what I said earlier. And yeah, little burrow there. Anyways, now once we have that done, let's configure our state chips to however many seconds you put in before 0.1. So I'm gonna put 3.1. You have 4 seconds. You got 4 seconds. 4.1. Yada yada yada. 3.1 for all of these, except for our door state. Your door state is gonna stay the same, except let's just put in a value of 2. So that it'll wait 2 seconds before actually resetting or trying to reset. So now, if everything works, if you did everything properly, it should be working. So we have this. The camera's not on it right now. So what's gonna play that? And we have the door closed. Our camera's not on it. It's still gonna progress. But as you see, it's not going. It is going to actually. So put it on the reset. Oh, instead. Yeah. Erase. So, if you haven't seen it, okay, so should be happening right now is it's doing everything properly, but it's still going ahead and jump scaring you. So, what you need is just copy and paste the compare chip we used for our camera, and then put the done output into that. Now we're gonna put and we're gonna check if door is closed. If it's not, let's get another compare chip. Let's get our scan chip earlier. And copy and paste our AND chip. You know, copy and paste your AND chip and the compare chip with a value of 1. So we're putting that in, and we're gonna put the done value into the other value of our AND chip, and the combinator chip value into our compare chip. So now it'll only allow it to be played if the door is not closed and the animation is done. So now it should be fixed. See, it just snaps back there. Sorry for the bug. Sorry for the bug. Sorry. But it's done now. Let's see, let's put our camera into where it's watching it. And you'll see now that it won't progress. Our camera, Foxy, will not progress while our camera's watching him. See, take it off him. And he goes ahead. Then he can go ahead and move. We didn't have the door closed that time, so of course he jump scared us, but there we go. That's the AI. That's gonna be the AI for Foxy type animatronics. This is the end of the tutorial, and I'll see y'all. Yeah.